Today we're going to look at significant figures for measured values, or sig figs. We're going to break this up into two categories. On the left we have numbers without decimals, and on the right we have numbers with decimal points. I'm going to start on the left. Some numbers without decimal points, some measurements without decimal points, such as 100 meters, 100 feet, 100 gallons, 100 joules of energy. Since this number does not have a decimal, we can use what we can call the arrow rule, where we're going to cross out the non-significant figures. We're going to start on the right side of the number and draw an arrow from right to left, stopping when we hit a non-zero. So since the two zeros were crossed out on the right, that means this number 100 has only one significant figure, the 1. This number has not been turned into 1, it's still the number 100, but those two zeros are not sig figs, but the 1 is a sig fig, which is why it has only one sig fig. Next example, 5020. This number, if we start again from the right, because there's no decimal, and we stop at the 2, again the 0 on the right gets crossed out, but the other 0 does not. It is protected by the 2. It's being blocked. So the number 5020 has 3 sig figs, the 5, the 0, and the 2. And the last number here, 35, if we start from the right and go to the left, there are actually no zeros to cross out. So this number, every digit here is a sig fig, but there are 2 sig figs in the number 35. So once again, if a number does not have a decimal, we can draw an arrow from the right to the left, crossing out zeros until we reach a non-zero number. Any number that is not crossed out is a sig fig. So again, the number 100 has 1 sig fig, 5020 has 3 sig figs, and the number 35 has 2 sig figs. Moving on to numbers with decimals, 0.054, this again is a measurement, centimeters, milliliters, something like that. But now we are going to draw an arrow from left to right. So a different rule when we have a decimal. Left to right, stopping once again when we reach the 5. So the 2 zeros get crossed out. Again, they're still there, they exist as part of the number, but they are not significant. They are only part of the placeholders, they're not part of the actual important part of the measurement for accuracy. So the 5 and the 4 are sig figs, 2 sig figs in this value. 0.054 has 2 sig figs. The next number, 0.20, we come from left to right. Cross out that first 0. The 2 and the 0 are sig figs, so once again we have 2 sig figs here. The final 0 here is a sig fig because the 2 is protecting it, it's blocking the arrow. And finally, 56.0, left to right. All these numbers are sig figs, the 5, the 6, and the 0, so here we have 3 sig figs. Many people ask, what's the difference between 56.0 and 56? It's the accuracy. The last 0 is meant to show more accuracy. If it was 56.00, we would have more sig figs showing more accuracy because different measuring devices show different accuracy. But to go through these decimal values, the first number, 0.054, has 2 sig figs, 0.20 has 2 sig figs, and 56.0 has 3 sig figs. So once again, numbers without a decimal, draw an arrow from right to left. Numbers with a decimal, left to right.